Today, I'm very happy to present our recent work on fine-tuning segmentation anything model to deal with anatomical segmentation tasks in medical images using Fewshot examples. The motivation of this work is that SAM requires user to provide points and bounding boxes as prompts, and this could be a challenging task for segmenting objects in a 3D image, in a volumetric image. Given the example on the right, so you see here there are two cases. The first case is a aorta segmentation task in a CT scan. You see here the yellow cross here is basically we mimic the point prompts for SAM. And in this case, SAM provides three outputs. The first output is pretty okay, the first column, but the other two are completely irrelevant. The last one is basically segmenting everything inside the chest wall, which is not very useful. And you probably already know that the SAM provide a way for you to filter out the bad segmentations. So instead of three segmentation outputs, SAM also output a predicted IOU for each segmentation. And then there is a stability score that you can also use to filter out the bad result. But in this case, we actually all three segmentation output are above 0.88 for the IOU and 0.95 stability score. So you cannot use the threshold. You cannot find a single threshold. And actually, the last case give you the best scores. So this is the why that using single prompts does not work for SAM. So you always have ambiguous output. This is also partially because in medical images, the target object and the neighboring object are not very easy to be, distinguishable because their features or in terms of intensities, there's no clear boundaries whatsoever. So one has to deal with this situation. One has to provide the negative examples or background points, for SAM to figure out where is the target object. But this can be very time-consuming. You can imagine, like if you want to segment a 3D object, you have to run SAM slice by slice. And for each slice, the user has to provide multiple points for SAM to find the target object, which could be very demanding. And therefore, in this paper, we propose to label a few images. Then we can use SAM's image encoder to extract labeled embeddings. We call it a Fewshot embeddings. And then we can later use these embeddings as prompts to query the target objects. So here we show you the method overview diagram. Basically, our methods keep the SAM's image encoder intact. We don't change any image encoder part, just use pre-trained the weights. We completely remove SAM's prompt encoder, so this part is gone in our approach. So this D here is the top box here is the original SAM. Then our approach is on the Fewshot prompting side. We don't use any prompt encoder. Instead, so we replace the prompt encoder with the process of extracting, label embeddings from a labeled Fewshot set images. The label embeddings are then used as queries here. Of course, we concatenate with the task tokens, and so this part is concatenation will be used as queries to find the target object in the SAM's mask decoder. So we basically only modify the mask decoder and introduce a process of extracting label embeddings as queries. So in the end, we relied on the embedding similarities learned in the two-way transformers in the SAM's mask decoder to find the object correspondence. So we experiment on 4 datasets. So 3 public available datasets. There are AMOS22, MSD, and VERSE20. We also collected 1 large-scale CT dataset internally, which is a knee knee dataset. In total, we have 6 anatomies. So it consisting of tibia and femur. These are the knee joints. Aorta and post cava. These are from Amos 22, and then left atrium from MSD, which is a variety source, and then vertebrae or spine from verse 20. We compare our methods with the UNet baseline, and then the SAM with a single point or bounding box as prompt. The quantitative results show that our methods with only 5 is the first you can see under the SAM column. Using a single point as prompts does not work for all cases, so the result is pretty bad. To use SAM, you have to provide the bounding box as prompts. You see, once you use bounding box as prompt, the results are pretty okay. You also see here our approach with only 5 labeled images. You see that result is already way better than the SAM using point prompts. So as you increase the number of labeled images until you reach 50 labeled images, the result is already on par with the SAM using box prompts or the UNet approach. The qualitative results, we can also draw the same conclusion from the qualitative results. Here, the first row is the T-snake plot. We want to see whether the SAM's feature, the embeddings from the SAM's image encoder is good enough for segmenting anatomical object in our experiments. You see, most of the cases, luckily, the SAM's embeddings are pretty okay in separating object, target object from the background. You see the vertebrae, the spine here. There's a little bit of confusion, but you still see there is a cluster forming for spine or for background in the image dataset. The bottom part of this slide is that we show 2 cases. Their qualitative results. The first one is the spine segmentation. The second one is aorta segmentation. The first column is the ground truth. Then you have the second to the third, and fourth column are our approach with 5, 20, and 50 label images. And then the last column is the UNet result. Then the fifth column here is basically the SAM, the vanilla SAM with box prompts. So keep in mind that when we mention the box prompts, these box are derived from the ground truth segmentation class. So it's not really realistic in the real world applications that the user has to give very accurate box. You always introduce the human errors. So here you already see that the proposed approach with 50 images achieves a pretty good result when compared with the UNet and the SAM with box prompts. To summary, we propose a Fewshot fine-tuning approach for applying SAM on segmenting 3D anatomies. The proposed methods reach the performance level on par with UNet and SAM by box prompting, with only 50 labeled images as a Fewshot set. We thank you for your attention.